Hello there everyone, my name is Naresh Kumar Chenappan and today I would like to present my final year project entitled Preliminary Assessment of Airborne Microplastic in UMT, Malaysia.
I was supervised by Dr. Noorlin Mohamad and co-supervised by Dr. Tuan, Nurul, Sabiqah, Tuan, Anuar.
Moving into the introduction. Microplastic pollution have been paid full attention by the world, and microplastic can be defined as a piece of plastic size smaller than 5 mm along its longest dimension. And this microplastic can be divided into two sources, namely primary sources and also secondary sources. And in general, microplastic have very light characteristic which enables them to be resuspended in the atmosphere. The finding of microplastic, especially in the atmosphere, will help other researchers to come up with a new solution to reduce its effect to humans and also ecosystem.
Moving on to the problem statement. Research of microplastic occurrence, abundance and toxic effect are mostly studied at the aquatic biota. Little attention have been given to the occurrence of microplastic in terrestrial ecosystems such as urban area and coastal area. In 2018, Gasperi concluded that inhaling suspended dust that contains pollutant will increase cancer risk to humans. So, a clear picture of microplastic in suspended dust, especially in Malaysia, will be a great finding and may help in curing many health-related issues to humans in the future. The objectives of this study is to determine the presence of microplastic in the air of coastal area by using passive sampling method, to determine the possible sources of microplastic using ATR-FTIR analysis, and to determine the morphology of microplastic in the air using SEM. Moving on to the methodology, this is the design of method, where it started from study area where 4 location was selected as shown in the picture, and sample was collected by using passive sampling method where it uses petri dish and filter paper. After sample collection, physical characterization was performed by using stereo microscope to count and visual sorting, and SEM was used to determine the morphology structure of microplastic. After that, chemical characterization was performed by using ATR-FTIR to obtain the molecular group, in this case monomers of polymer, and EDS was used to determine the elemental composition. And finally, data analysis was obtained and recorded. Moving on to the results and data. Figure 1.1 shows the abundance of microplastic for each location in this study. From the bar graph, it clearly shows that S2 recorded the highest abundance of microplastic, whereas S3 recorded the lowest abundance of microplastic. Figure 1.2 shows the percentage of microplastic color in the airborne sample, and from the pie chart, it was eminent that transparent was the dominant color as it recorded the highest percentage at 29%, and the least percentage was recorded by purple and orange color at 1% each. Similar to this study, Abasi in 2019 have recorded transparent microplastic as the most abundant microplastic in the atmosphere from Asulia County in Iran. Figure 1.3 shows the images of microplastic from the airborne sample, and the images shows that microplastic from the airborne sample is in fiber shape. These images was observed using stereo microscope and captured by using Dino Capture 2.0 software. Figure 1.4 shows the spectrum for microplastic according to the color type. By using the spectrum, the type of polymer was determined for each color type of microplastic. It was concluded that blue and transparent color type of microplastic was polyethylene, red was polypropylene, and black was polyester type of microplastic in this study. Figure 1.5 shows the SEM images of microplastic. The SEM images shows that the microplastic had been undergone oxidative and weathering process through the crack and twirl formation on its surface. Besides that, it had other fibers and biofouling sticking on its surface. Figure 1.6 shows the EDS spectrum of microplastic according to color type. The presence of elements such as boron, silicon, cadmium and aluminium shows that microplastic is vulnerable in absorbing heavy metals, and this shows human beings are at higher risk of getting cancer by inhaling microplastic that binds with pollutants. General sources that significantly contributes to the abundance of microplastic was determined in the studies. For example, fishing activities. Polyethylene can be degraded from the fishing rope from the fishing activities. Besides that, traffic activities. These activities can cause the abrasion and weathering process of car tires. Other than that, degradation of traffic cones can also causes abundance of microplastic in the atmosphere. Many locals in Terengganu still practice open land burning. Burning of plastic can cause small fragments of plastic to suspend on the atmosphere. Other than that, clothing such as polyester can also increase the deposition rate of microplastic in the air. Movement of students and staff in the university helps the microplastic to resuspend in the atmosphere. Wind movement will help the microplastic to travel up to 95 km, and this causes the abundance of microplastic in the air.
In conclusion, this study proves that microplastic is present in the atmosphere. This is due to the factors that contribute to the abundance of microplastic in the atmosphere. ATR, FTIR analysis determine the type of polymer for each color type of microplastic. The sources of these microplastic were determined from clothes, socks, jackets, traffic activities and also fishing rods. Physical analysis showed that most of the microplastic present in the atmosphere is in fiber type. SEM analysis confirmed that microplastic present in the air is exposed to weathering and oxidative process, whereas EDS analysis showed the presence of heavy metals such as cadmium and aluminium in its surface. This shows that microplastic can be bind easily with pollutants. The future work will be to improve in the analysis method and allow it to be used in a variety of applications. A better sampling approach by using low volume sampling in active sampling should be used as it is convenient and time saving. More studies on airborne microplastics should be done to assess their pollution status in each region of Malaysia and their potential risk to human beings.
This is my acknowledgement and this is my references. Thank you for listening.